do them all in one. So I'm trying to break it up like this every time. So this is still 5.7, okay? But we're talking about 5.7 trig substitutions. And the general idea is that the general idea is if you have a trig, you have a triangle, right? You have a right triangle, better yet. If you have a trig, you have a right triangle. And I would love to keep everything in terms of sines, cosines, and tangents. And so I'm trying to organize my triangle so that those are the main things that come out of it, okay? So, but the general idea is, so you're going to be drawing triangles for here. If I ask you to do a trig sub and you don't give me a triangle, then you have magically figured out a way to do the problem in your head, or you use some computer program to do it. Now, there are other methods, but they give you what the U sub will be. And what I want you to be able to do is figure out what the U sub will be, okay, or the theta sub, right? So I want to look at a right triangle. And of course, I'm going to have side A, side B, and hypotenuse C, right? I'm looking at a right triangle. And I want to generate from this the Pythagorean theorem, right? And this is going to be plus B squared equals C squared. And I'd like to solve for A and C, okay? Maybe I should solve for B as well. But let's solve for C first. So C would be square root of A squared plus B squared. And we're assuming the sides of the triangle are positive. So we don't care about taking a square root and getting plus or minus at this point, okay? So if I see a sorry, 1 second. I'm just looking at old tests. I want to have a problem ready. Ah, here we go. If I see a problem like the second problem here, I can see I have a hypotenuse. So I'm looking for a square root of something squared plus something squared. If that's the case, I have a hypotenuse. Yes, you with me? If I solve, so first of all, I'm just trying to figure out, do I have a hypotenuse or do I have a leg of a right triangle, right? So if I solve either of these for A or B, I get the square root of C squared minus B squared, or the square root of C squared minus A squared. So looking at problem 1 and problem 2, you can see that I have a leg. If you could see me standing, you would know I have a leg. No, that's maybe not true. So, but in this case, when I have a square root of something squared minus something squared, I'm thinking I have a leg of a right triangle. And when I have a square root of something squared plus something squared, I have a hypotenuse of a right triangle. So that's your first goal. Look at the problem. See if you recognize a leg or a hypotenuse, right? It's not some previous method. Okay, but of course Robert's going to say to you on the midterm, use a trig substitution. So you almost could ignore the other methods, right? But you're going to have to still decide if you have a leg or a hypotenuse problem type, right? Once you decide that, you've got to figure out what your hypotenuse is, okay? So in both of these situations here, in all three of these situations here, right, the hypotenuse is C. And but look at this one. What's my hypotenuse there? Can you tell? Charlie? Eleanor, sorry.
1.
1, very good. So I'm trying to relate where that hypotenuse is, right? Where the C value is in my green circle. You see my green circle? Where is that 1 in terms of, so, right? So I'm looking at this and going, okay, it's a leg. So it's got to be one of these two. So C is my hypotenuse, so it has to be 1. Now, here's the subtlety. All right, so what's my process here? Step by step, I'm going, right? I'm going to go, okay, is it, do I have a leg? That's funny. Do I have a leg or a hypotenuse? Right? Find the value of C and or A, right? When possible. And this is the key. This is one of these subtle things that no book is going to say. This is just, I don't know if my dad taught, my dad was a math teacher, high school math teacher for 50 some years, but, and I failed every high school math class. Still somehow ended up here, I don't know. But this is a subtlety that will just make your integrals easier. When possible, let your hypotenuse or your height be labeled x. So in this particular problem we have here, okay, I got to finish that. Let me finish that, and it won't make much sense here. But so step by step, do I have a leg or a hypotenuse? I'm looking for that square root symbol, right? Find the value of the sides if I can, right? Then I'm going to label, and I'm going to try and label either my hypotenuse as x. Right now I know this problem I have, it's 1. So then I'm instantly going to label my hypotenuse as the height as x. In doing so, I'm going to create trigs like sines and cosines and tangents compared to cosecants, secants, and cotangents. So I'd rather integrate in terms of sines, cosines, and tangents. So then we're going to make our substitution. I'm sorry, complete the triangle. Sub or x square root of and dx. This is the key, and it will make sense when I do a problem. I got to make sure I make a substitution for everything. I'm changing my variable to theta, okay? So I have to find a trig for x. I have to find a trig for square root of. I have to find a trig for dx. I have to find a d theta for dx. Solve the integral. Sub back into x terms using the triangle. There's our whole process. And you can see it's pretty friggin' complicated already. You don't know what the hell's going on yet, but I'm just giving you kind of the directions. I'm telling you how to get to my house, right? Turn right at the building with a big yellow M on the roof, and you're like, what the hell is he talking about? But then you get there and you see it's a McDonald's, and right. So I got the directions written down. They don't make sense until you do them. And of course, the second time you drive there, it's easy, right?
So for these problems, we should always draw a triangle?
Yes. And all my students that don't draw triangles and come up with a crazy answer, I always say to them, I try to have meetings with everyone who fails the test, right? That's what I would like you to do. Meet with me and go over it. But I'll say to them, well, how'd you do this problem? And they say, I don't know. I said, what? How'd you do the problem? They said, you got all this work on the page. How'd you do the problem? I don't know how I did it. What? Okay. Hopefully, you know, I understand you need to take a shortcut every now and then, but you know, you're going to be doctors, or you're going to be building buildings or bridges, or you're going to be controlling aircraft with a computer program. You know, you're going to be manufacturing drugs that could possibly kill someone or save their lives. So you want to put yourself through the real rigor. Make sure you're a master of things, right? And yeah, it sucks. But just like being born was very, very painful. But we don't remember it because life is, even when it sucks, it's pretty damn good, right? So we don't remember the pain. And it's going to be the same thing when you get through this Calc 2 class. You won't remember the pain. Eventually that pain, you won't, it's so joyful to move on and to have this intelligence that you will forget how painful it was, right? Especially when you're done with your bachelor's degree. It's a great moment. Master's degree is even better. And then some of you will be doctors, which is nice. Okay, let's do this first problem, see how we do, right? So I've got the integral of 1 over x squared square root of 1 minus x squared dx. I've already decided that I have a leg of a right triangle, and of course I have a right angle in there, and I have theta as my base angle, right? Every time. I have realized that my hypotenuse is 1, right? Does everyone agree with that? And so since I have the height open, since I have my height unlabeled, I'm going to label it x. I would like to choose either my hypotenuse or my height is x whenever I can, because it will make things easier. Sometimes it doesn't matter. Okay. So, but if you can imagine here what trig works for theta, just with my two sides here, what trig works with my theta here? What trig do I have present right now?
Sine.
Yeah, sine. So sine of theta is x over 1, right? And that's nice to integrate. What if I put x here? I still have a trig, right? And this one is in particular cosine. It's not a big deal, right? It's no big deal which one I put here. But I'm saying sometimes when the problems are pretty complicated, this little subtlety of what I have figured out is let the hypotenuse or the height be x. So now my other side by Pythagorean theorem is 1 minus x squared. And by the way, if right? If I see my labels here, C is 1, B is x, A is square root of 1 minus x squared. It's exactly what I had up in that green circle when I solved for C, and I solved for B, and I solved for A, right? Okay, we're done with, let's see, 1, 2, 3, 4. We're done with step 4. We've completed the triangle. Is everybody comfortable here? Nice. Sarana's okay. Ash is all right. Adam's okay. David, nice. All right, so I'm ready to, now look at what I have in my trig, in my integral. I have an x, which means I can get the x squared once I get x. I have a square root of something, right? I already know it's side A. And I have a dx. And so every piece has got to be I have to change into variable theta. So the easiest thing is to always start with x, right? So I need is x over 1 is sine of theta, or better yet, sine of theta. X is sine of theta is enough, right? So once I have x squared, right? So that means what? X squared is sine squared theta. Yep, you with me? And once I have x, I have dx. So what's dx? What's the derivative of sine?
Cosine theta.
Nice. So cos theta d theta, right? We want to use those differentials. Notice that the derivative on the left side was with respect to x. The derivative on the right side was with respect to theta. Remember, dx is that with respect to what variable, right? The integral of sine of x dx. Antiderivative of sine of x with respect to the variable x, right? Now, the only other thing I need is the square root of, and I notice that the square root of 1 minus x squared over 1 is what? Cos of theta. Right? You see that? So now I've got everything I need, and this is the goal. And remember what I said. What are you going to forget most of the time? The dx. So the dx is done, right? We got the dx done. We got the x squared done, right? We got the x squared done, and we got the square root done. Right? We got that square root done. So now step 5, substitute. We're changing our variable to theta now, right? So my integral of 1 over x squared square root of 1 minus x squared is now the integral of 1 over x squared is sine squared theta. Square root is cos of theta, and dx is cos theta d theta. So I made all my substitutions. It's going to work this way every time. This was on last semester's final exam, by the way. This is an easy problem. I don't know why I put this on. It's too easy. Oh, I know why. Because I tortured them with the midterm, and I promised them that the final would be easier, and I did make it easier. So cos theta's canceled here.
Hey, Professor.
Yes, Josh, what's up?
Do you think you'd average it out for us? For both the midterm
I
and the
promise I will never give an exam that difficult again the rest of my life. The rest of my life.
Again?
I'll never give an exam that difficult again. Never. Never. It was not worth all the tears and the screaming and the crying, and that was just me doing that. So now I can see that I have a 1 over sine squared, which I know is cosecant squared, theta d theta. And that's a simple integral, right? That's minus cotangent of theta. I guess I kind of want to do a plus c here, but I can wait. Whatever, plus c, who cares? But I want to remember I'm not done yet. I just did my integration. Is everyone okay with that integral, by the way? Derivative of tangent is secant squared. Derivative of cotangent is minus cosecant squared, right? So antiderivative minus cosecant squared. But you'll have all of that stuff on your formula sheet if you forget. So now I've got the integral of 1 over x squared square root of 1 minus x squared dx is I'm looking for the ratio of my cotangent from my triangle, right? So cotangent is what? Adjacent over opposite, right? So minus square root of 1 minus x squared over x plus c. So remember, convert back to the x's using the triangle. It's pretty tough. It's pretty tough, but you're just the checklist is going to work for every problem, okay? But the real issue is that the problems will turn into integrals that you'll have to do by parts, or there'll be power reductions, or etc. Right? So you just have to be patient, trust your abilities, know that you have practiced enough. Right? So we should definitely do another one. Let me grab one from the book. So by the way, the problems I like in MindTap, and I've already put this up on the schedule, I've updated it, are 11 through 17. So the problems I like for this particular section from 5-7 is number 11 through number 17. And there's a couple of examples too. I don't redo the example in the lecture. I don't do the examples that are in the book because they're good for you to do, right? Because it's already worked out for you. So you could, when you read the book, that's the simplest way to read a math textbook is to do the example problems, write it down, do the work yourself, double check and see if you've done what the author has done, right? Then the next level of reading is reading how they came up with the theorem or even proved the theorem. And you'll see their process for trig substitution is completely different than mine. It isn't really, but it's not as, I don't think it's as clear. But, you don't have to do everything the way I do it. But so 11 to 17 in MindTap and homework 4 is trig. I think it's only 2 problems in the trig sub. So yeah, so let's try number 12 here. I don't know how easy it is, but we'll see. So I don't want to do 11 or 13. I don't want to do the odds. I want you to have them to do, right? And then I'm going to give you some Shawm's trig subs. And there's Paul's notes, trig subs, if you want, right? So we're doing the integral of square root of x squared over x to the 4th dx. That's an x to the fourth. And so what do I have? A leg or a hypotenuse? And then how can you tell quickly?
The top one is a leg.
It's a leg. When there's a negative in between, it's a leg. When it's a positive in between, it's a hypotenuse. It's that simple, right? All right. Can you tell for me someone different?
Can you say that again?
Yeah. When it's a negative, so inside the square root, there's a negative in between. It's a leg.
Mm-hmm.
And if it's a positive in between, it's a hypotenuse.
The hypotenuse is x.
Okay, good. So now I'm looking for, and I was just about to say anyone but Chuck. Tell me what the hypotenuse. That's okay, Chuck. I don't mind. The hypotenuse here is x, right? Remember we had that a equals square root of c squared minus b squared. It's always going to be hypotenuse squared minus the other leg squared, right? So that makes it easy for us. I can put the x there with no problem. Now, this is the part that's iffy in my process. When the hypotenuse is x, does it matter which side I label 1? In this case, 1. Probably not, okay? But I would rather deal with secants than cosecants. So if you can see, which side should I label 1 if I want secants?
Vertical side.
Yeah. So secant is 1 over cos, right? So I want that adjacent, right? And then my other side is going to be the x squared minus 1. So the only part, now, would it matter? No. What's going to be the difference? What's the antiderivative of, right? What's the derivative of secant? It's a secant tangent. What's the derivative of a cosecant? It's a negative cosecant cotangent. So the only thing I'm saving you here in this case is a negative sign. Okay? But both will work. Okay? So you almost have freedom on this one. Once you decide the hypotenuse is x, you can do any side. You can label the other sides any way you want. But my real choice is try and get the hypotenuse to be x or the height to be x. A little counterintuitive, right? Because you would think the x would be the adjacent side always, because that's the x-axis. But okay, so I need an x. What is my x? Secant of theta, which means I know x to the fourth. That's secant to the fourth. And I also know dx. That is secant theta, tan theta, d theta. Don't let me go too fast here. I think setting up the triangles is the harder part. Once you get that, it's pretty easy. We okay? Anybody need a minute? We're almost done for today. It's almost time for lunch. Hopefully it doesn't rain all day.
Could you explain again why we're working with secant?
Just because I'm saving you a negative sign. I'm trying to be as positive as I can. So derivative of secant is secant tangent. Derivative of cosecant is negative cosecant cotangent. I'm just saving you a negative. I'm trying to. It doesn't matter in this case, Ash. It doesn't matter. In fact, you should try them both.
Okay, I was just wondering if it changed because of how the integral was set up, or
No, it's all about your choices, and I've done the work for you. I know that the integrals will turn out better this way. Okay. So again, it's hard to trust me. I mean, look at me. How the hell could you trust me? You can't. But I'm telling you, right? I've tried to. Some of this stuff I tried to come up with. Most of it I've been taught, right? And I'm just giving passing on that knowledge to you to try and make things easier for you. But Okay, we're ready. I need the square root, right? So square root of x squared minus 1 over 1. Why am I doing it over 1? I'm trying to make something as simple as possible, right? So this is what? Tangent of theta. And now I've got everything I need, right? How are we doing here? Okay. We're almost done. I can sense the backache and the headache and the trig ache. So upstairs I have a tangent of theta times a dx, which is what? Secant theta tan theta d theta. And downstairs I have a secant to the 4th theta. So it looks like I have a tan squared theta d theta over a secant cubed theta. So now we need some help here. We need to think about what's going on here and how we could possibly solve this. And this is sometimes the tough part about this. What I tend to do is I tend to go back to my pre-cal days when we had identities. And one of the things we did when we were proving identities, we turned everything into sines and cosines, right? We turned everything into sines and cosines. So I still go back there. You remember doing those trig identities in pre-cal?
Yes.
Yeah. So it usually turns out that this will be some kind of trig identity. And so I want to go, okay, this is a sine squared over cos squared times cos cubed d theta. So yes, you agree with that? And you see it's you're going to see it's turning into one of my trig power integrals now, right? So it looks like I get the integral of sine squared cos, right? Sine squared theta cos theta d theta. And I've got the singleton I need, right? It already turned into my singleton problem. That singleton is my du. So it's telling me what's my u. It's hinting at me what is the value of u here. What's the value of u here? Go ahead, Chuck. Yeah, sine theta. And so du is cos theta d theta. Okay, I like that. So I go of u squared du. Don't let me go too fast. I feel like I'm going too fast because I'm thinking about lunch.
I thought you just said that the singleton was going to be u.
Du. The singleton will always be du.
Oh, okay.
Yeah. And the problem is, so Eleanor, if you make u cosine, then you don't have du anymore. You have du squared. And so we don't deal with a differential squared ever, right? We only want that differential to be a singleton. Does that make sense what I'm saying? If I have cos as u, right, then du is sine, but I've got a sine squared. And so that would give me a du squared. But we don't want our differential to be squared. We always want it to be in what variable is it in? What single dimension is it in? So forget all I said. Du, the singleton is the du. So then pick your u from what's left over. Yeah. So what do I get here? I get u cubed over 3 plus c. And u is sine, so sine cubed So I know now my original problem of square root of x squared minus 1 over x squared dx. And I'm going back to my triangle. Sine is the square root over x, right? So square root of x squared minus 1 over x all cubed times a third plus c. And the book will probably do x squared minus 1 to the 3 halves over 3x cubed.
Isn't the left side of the integral supposed to be x to the fourth power?
Yes, thank
And
you.
the
Thank you. Yes.
Okay.
I just got it. Thank you. What's nice about these is if you take it's a nice little quotient rule review, right? That you take the derivative using the quotient rule and see if you get back to the original. So let's definitely try one of those on your own. So I owe you a couple things. I owe you some Shalm's pages. Not much else, I don't think, right? Do I owe you anything else? Did I promise anything else? I don't think so. So some Shalm's pages. A couple days off. I don't owe you that. You earned it. Next week will be a full 4, right? For the rest of the time, we're meeting all 4 days, right? For the rest of the week. I'm really happy with everything that's happening so far. I like the questions. I like the attendance. I've got 4 of you, maybe up to 6 of you with cameras. If you get the profile pictures up, I'm okay with that. I'd rather have more cameras on, but that's your choice. I can't stop you. I do say if you came into the classroom like wrapped in let's just say you got a bag on your head, right? I can't even see your eyes, nothing. I'm going to freak out a little bit. I'm going to laugh at first, and then I'm going to get scared. But hopefully you'll talk to me at least through the bag. What do you think? What do you think after the first week? Any comments? Let me start my recording. So now, I of course I could do more examples, right? I could do more examples.